Check this.
Okay, welcome back. In the last video, we went over piecewise functions, and I gave you a function that looked like this, which is a piecewise function, and you had to graph it. Today, we're going to be doing the opposite. Today, I'm going to give you the graph, and you're going to transcribe it into a properly formatted piecewise function like the one over here. Okay? So we're going to be going backwards. Now, in order to do that, we have to know how to write equations of lines. So it might be a good idea to do a little warm-up here that involves writing equations of lines. So a little Algebra 1 review to get us started, and here we go. Write the equation of a line, put the line into y equals mx plus b form that has each of the three things that I have here. So the first one is write the equation of a line in y equals mx plus b form that has a slope of -2 and passes through the point 0, 4. So here we are at Desmos. Once again, we're going to write the equation of a line whose slope is -2 and that passes through the point 0, 4. Before we write the equation, let's do this visually. Okay, where is 0, 4? The x is 0, the y is 4. So if the x is 0, you're in the center of the graph. You're not on the right, you're not on the left, you're on the y-axis. So there's your 0 for x, and your y means go up 1, 2, 3, 4. So there you are, you're right there, and that is the point 0, 4 right there. Okay? Now we need to draw a line through that. Okay? Now our line that we're looking for happens to have a slope of -2. Now what I'm going to do is show you what it looks like to have a line drawn through that. So if our y-intercept, okay, so this is a y-intercept. If our y-intercept is 4, and we draw a line through that, there you go. If the slope is 0, then you have a horizontal line. If your slope is positive, like positive 0.5 or positive 1 like that, then you're going to go uphill. Now remember, you read your graphs from left to right. This is not downhill, this is uphill because we read our graphs from left to right the same way we read English, okay? So this is uphill, and if the slope is 2, it gets more steep. 3, more steep, steeper, steeper, steeper still, right? It goes up. If you go back to the horizontal, that's 0. And if you go downhill, that's negative. So negative 0.5, negative 1, negative 1.5, negative 2, so on and so forth. It goes downhill in the same fashion. So you can see your slopes go from positive down to 0, down to negative. Now, what we want is a slope of -2, which is this one right here. So we want a line that has a slope of -2, like this one has, and has a y-intercept of 4. What would be the equation of that line? Well, simply put, you just use y equals mx plus b here, okay? You just go here and you plug in a -2 for your m, right? Because that's your slope, and you plug in a 4 for your b, okay? All right, so that would be y equals, your answer here, -2x plus 4. Pretty easy, because this was a y-intercept. It was a y-intercept because this is a 0. Now look at the next question here. Has a slope of -2 again, but this time passing through the point 3, 4, not 0, 4. Now with 3, 4, you don't have a y-intercept, so everything changes. And I'll show you how to deal with that. So this time we have a slightly different question here. Now it's write the equation of a line whose slope is -2 but passes through the point 3, 4, not 0, 4. So where is 3, 4? This time your x is 3, so starting from here you're going to go 1, 2, 3 to the right, and then you're going to go up 4, and you end up here. So that is 3, 4 right there. Now that is not a y-intercept because you're not on the y-axis. So unlike last time where we had a y-intercept and we were able to say, hey, b was 4, remember that? We don't know that this time. We don't know where the y-intercept is, okay? So here's what I mean. If you draw a line through this point, depending on the slope, that could be your y-intercept, that could be your y-intercept, that could be your y-intercept, right? So your y-intercept could be anything. It doesn't matter that this point is 3, 4. It depends on which way your line is going. Okay, so if you have a line that happens to be going, have a slope like this, your y-intercept is way down here. So you know nothing about your y-intercept. You don't know what your b is. So in a situation like this, you don't know what b is. You cannot use y equals mx plus b. Okay, so we just saw that we're not on the y-axis, so we don't have a y-intercept. So we can't just simply do what we did last time, which was plug in the slope, which is -2, and plug in the y-intercept, which was 4, to get an answer nice and quick like we did here. we have to do a little more work. So in order to do this, we're going to use something called the point-slope form of a line. Okay, it's an equation that looks like this. All right, y minus y1 equals m times x minus x1. And we use this when we do not have a y-intercept. We don't know what the y-intercept here. I showed you on the graph that it's not 3 and it's not 4. It could be anything, right? So how do you use the point-slope form of a line? Well, you need to have a point and you need to have a slope. It's right there in the name. What's the point that we have? Well, it's right here. It's 3, 4. So that's your point, 3, 4. And what's your slope? Well, your slope is -2, okay? Your slope is still the letter m. So just like in y equals mx plus b, you're going to plug your slope into m. But what's your point? Well, your point, 3, 4, your point is going to be labeled as x1, y1. So what's your x1? Your x1 is this 3 here, and your y1 is the 4. So x1 is 3, and y1 is 4, okay? And when you do that, you get this. Y minus y1 becomes y minus 4 equals -2, x minus 3, and that's your answer in what's called point-slope form, okay? That's not in y equals mx plus b form. You can tell from the parentheses and the fact that there's a -4 on this side of the equation. This is point-slope form, and if you were in AP Calculus, this would actually be your answer. You would stop here. Okay, we use point-slope form in calculus a lot, so we have to learn it now. And you know, you're supposed to learn it in Algebra 1. There is a shortcut, or not really a shortcut, but an alternate method where you solve for b, but we're not going to do that. We're going to do it the right way so that we have the right tools in the future. So there's your answer in point-slope form, and we're not going to box this because I did explicitly say your answer has to be in y equals mx plus b form. So you need to do a little more work, just a little more work to make it y equals mx plus b. Now you notice with y equals mx plus b, there's nothing next to the y. The y is by itself. You see that? So one of the things you're going to have to do is get rid of this -4 over here. How do you get rid of this -4? Well, you can just add 4 to both sides. And now you have y equals, which is what you want. But then you have this -2 times x minus 3 plus 4. Okay, that still doesn't look like y equals mx plus b, but it's getting closer. Now what can you do? Well, if you take a look, there is something you can do here, PEMDAS-wise. You can distribute the 2, right? So go ahead and distribute that 2. Now you have y equals -2x, -2 times -3 is positive 6 plus 4. And finally, combine like terms, you get y equals -2x plus 10. And now, that's a y equals mx plus b equation. So that is the kind of answer we wanted. And now you could tell, if you had drawn the line, your y-intercept would have been a 10. Let's go ahead to Desmos and take a quick look at that and see if that's true or not. Okay, so here we are in Desmos. There was that point that we had to satisfy, 3, 4, and then we wanted to draw a line whose slope was -2, meaning going downhill like this, and we wanted to see where it hits the y-axis. Now, we said our answer was y equals -2x plus 10. Does this line go through that point? Yes, it does. Does it have a slope of -2? Well, let's see. We go down 2 over 1, down 2 over 1. Yep, down 2 over 1. It does work. So there you go. That's the equation of the line in y equals mx plus b form. Okay, for this last warm-up problem, we're going to be finding the line in y equals mx plus b form again that passes through these 2 points, -2, -6, and 3, 4. Okay? Now, from the last 2 problems, we saw that we could use either y equals mx plus b if we knew the slope and the y-intercept, because this thing is called slope-intercept form. So in order to use it, you need to have a slope, which is your m, and a y-intercept, which is your b. They really should call it slope y-intercept form. So if you don't have a y-intercept, you're going to use point-slope, which is this equation right over here. How do you use point-slope? Well, it's right there in the name. You need a point and a slope. And that's what we did up here, okay? We had a point, 3, 4. We had a slope, and we plugged in the point, we plugged in the slope, and we were done. Well, a little bit of algebra, and we were done. Well, here, what do we have? We have 2 points. We don't have a slope. So actually, we can't use either of these. We don't have a slope because you need a slope for slope-intercept form, and we can't use point-slope form because you also need a slope. So we can't use either of these. What do we do when we have 2 points? Well, if you remember in Algebra 1, there was this thing called the slope formula. M equals rise over run. So rise would be the difference in your y values, and run would be the difference in your x values. So how does this translate here? Well, let's come up here and label these points here. Let's say this is an x, and this is a y, and this is another x, and this is another y. Okay, so both of these are x and y and x and y. And if I said to you, what is x, you wouldn't know which x I was talking about because there's 2 of them, right? So to clear that up, we use these little subscripts x1, y1, x2, y2. The reason why we have the subscripts is so we can tell which point we're talking about. So this is the first point, so everything has a 1. This is the second point, everything has a 2. It doesn't matter which is which, it just matters that you're consistent. You don't have like x1, y2. All right, so how do you find the rise? Well, it's your y difference in your y's. So your ending y is y2 minus your starting y is y1. And then your difference in your x's, x2 minus x1. So m equals y2 minus y1 over x2 minus x1. That's something that most people also remember about Algebra 1. Okay, so we're going to use that to find our slope. And once we do that, now we can go ahead and use one of these formulas because we'll have the slope that we need. Okay, so here we go. y2 is 4 minus y1, which is negative 6. So you're saying minus negative 6. So that's a double negative right there, which is going to become a plus. And now here you have x2, which is 3, minus, and then your x1 is negative 2. So also a double negative here. So what do you get? 4 minus negative 6 is 4 plus 6, which is 10. And 3 minus negative 2 is 5. Because that becomes a plus, and because that becomes a plus. And 10 divided by 5 is 2. So now we have a slope. Do we have a y-intercept? Because if we have a y-intercept, we can go to y equals mx plus b, which is faster and everybody's favorite. Is either one of these points a y-intercept? Unfortunately, no, because neither one begins with a 0. Your x has to be 0 if you're on the y-axis, and that's not happening here. So we need to use point slope. We're going to have to use point slope here. Yeah, what can I tell you? So anyway, that's fine. We're going to do it. We're going to use point slope form. What's our point? Well, we actually have 2 points. You could choose either one. Choose the one that you want. It doesn't matter which one you use. So you have these 2 here, and you have these 2 here. These 2 numbers here. This point has negatives, and this one doesn't. So you know what? Let's go with the easy one. Let's go with the one without negatives. Let's go with 3, 4. So our point is 3, 4. So we have a point, we have a slope. Let's use point slope form now. It's y minus y1. Well, I know I labeled this x2, y2 over here, but for the purposes of point slope, it's going to be x1, y1, because there's only one point in this that we're using here. So our y1 is 4, equals m, this is m right here, which is 2, okay, times x minus your x1. So x minus, and the x1 in this case is that 3 right there. So there you go. That's the answer in point slope form, okay? And if you were in calculus, you'd be done already. However, in Algebra 2, we usually ask you to go to y equals mx plus b form. So let's keep going. How do you get this by itself? Remember, you have to get rid of the 4 here, and you have to distribute the 2. I'm going to distribute the 2 first this time, only to show you it doesn't matter which one you do first. This becomes 2x minus 6, right? And then we're going to add 4 to both sides to get rid of this negative 4. And this becomes y equals 2x minus 2, because negative 6 plus 4 is negative 2. And there's your answer right there. Okay? So that's a little review of how to write the equation of a line if you have a slope and a y-intercept, if you have a point and a slope, and if you have 2 points. Okay, feel free to rewind that as much as you need to. There's your Algebra 1 review. So now that we know how to write the equations of a line, let's talk about transcribing piecewise linear functions. So I have some notes here that you can read when you look at the lesson that I post along with the video. All right, but if you just follow me, you'll understand how this works. All right, so now what we're going to have to do is figure out the equation of the line for each one of these pieces here. Okay, so we're going to have a y equals mx plus b for this one here. Okay, a y equals mx plus b for this piece here, and a y equals mx plus b for this piece here. And then once we have all 3 of these, then we're going to merge all of these into a single piecewise function by writing y equals, a single y equals for all of these. We're going to write this brace here, okay? And then we're going to take the mx plus b side of each one of these and just stack them up over here. So the blue one here, the red one, and the turquoise one here, mx plus b. For each of these, there's going to be also a domain, because obviously you can't just have this without telling me where they live. That's how you avoid violating the vertical line test. You need to say, well, you know, this one only goes for x is less than or equal to 5, apparently. So that's going to be 4 x is less than or equal to 5. This one goes from negative 5. This one goes from -5 to -2, so -5 less than x less than -2. Well, I'll show you how to do this in a minute. This is just a really quick intro. And then this one goes from -2 on, so x is greater than or equal to -2. And that's what your answer is going to look like, and that's the properly formatted form. You have to have the word FOR here, or you could put a comma, either way. So the textbook will sometimes use a comma, sometimes they'll use the word FOR. But it's this equation for x is less than whatever, this equation for this equation for this. Okay, so that's the strategy. How do we write these equations? Well, luckily we now know how to write the equation of a line, okay? And we're going to do that several times here. So let's go ahead and start that. So for this first piece over here, okay, do we have a point? And yeah, we do. This point is -5, 6. So for the, we'll do it in color coding again. For the blue here, for piece 1, we have -5, 6 is our point. Do we have a slope? Well, the line is horizontal, so the slope is 0. Okay? Now the question is, what do we use? Do we use y equals mx plus b, or do we use point slope for this one? Okay, well, we have a slope and we have a point, and that point is not a y-intercept. How do we know it's not a y-intercept? Because there's no 0 here. And you can just see it's right here. It's not on the y-axis. So we're going to have to use point slope. We're going to have to use this right here. So here we go. Y, this is your y1 right here, right? And this is your x1. Y minus y1 is y minus 6, okay? Equals m, which is 0, times x minus x1. So x minus, and x1 happens to be negative already. So this becomes y minus 6 equals 0 times all of this stuff here. Well, guess what? That means that all disappears. So we get that. And we need to get the y by itself. So this becomes, we can add 6 to both sides here. And this becomes y equals 6, which is a horizontal line through 6. And you can see that this, if we had the whole thing here, that would be the horizontal line going through 6. If you looked at this right here, that is y equals 6 right there. That's the horizontal line, y equals 6. So that makes sense. So we have one of our 3 equations here. So we can come over here, start our piecewise function, y equals, open brace. Now, if you have a hard time drawing the brace, some people, they don't know how to draw it at first. You could start by drawing a bracket and maybe just put like a little bump there at first until you get used to the idea. But it's a more curvy kind of brace there like that. And this first one here is going to be 6. Okay? Now, is this an open or closed circle? It's a closed circle. And which way is it going? It's going to the left. So this thing exists where y is less than and equal to, because it's a closed circle, -5, which is where this is, right? So you have to write comma, x is less than or equal to -5. Or, like I said before, you could write the word FOR, for, so for x is less than or equal to -5. You can do whatever you want there. For or a comma, it's your choice. All right, what about this second piece here? Well, this second piece has 2 endpoints. It doesn't have like a point and a slope. It has 2 endpoints. All right, what's the endpoint right here? Well, this looks like -5, 9. So this one, we'll do this one in red. You have -5, 9, and what's the other point here? It looks like -2, 6. All right, so what do we have here? We have 2 points. We can't use either of these until we have a slope. So the first thing we need to do is find the slope formula. So this is going to be x1, y1. This is going to be x2, y2. All right, just separate these here. And let's use our slope formula to find the slope. So here's our slope formula. And it's y2 minus y1, so 6 minus 9, over x2 minus x1, which is -2 minus -5. A lot of negatives there. But don't forget that middle double negative there becomes a plus. So 6 minus 9 is -3 on top. And on the bottom, -2 plus 5, or 5 minus 2, if you will, is 3. So your slope is -1. Okay? Now, you have your slope. You also have 2 points. You have this point and this point. Are either of these a y-intercept? No, because they don't start with 0. And you can plainly see this is not a y-intercept, it's not on the y-axis, and this is not a y-intercept, it's not on the y-axis. So we can't use y equals mx plus b. All right, we're going to use point slope again. So y minus y1, I'll use this first point here this time. So y1 is 9 equals m, which we said right here, the slope is -1, times x minus x1, which we said is -5. And now, come down here, this is y minus 9. We can distribute this -1 here. -1 times x is -x. -1 times, well, this is actually a double negative, so this is +5 now, right? So -1 times 5 is -5. Last thing is to get rid of this 9, so we'll add 9 to both sides to get rid of that. And we get y equals -x, 9 minus 5 is 4. So we can take that one now and add it to our piecewise function up here. This is -x plus 4. Now, where does this live? Okay, x as far as x is concerned. Okay, well, this starts at -5 open circle and goes to -2 open circle. So -5 on the x's to -2 on the x's. We're just talking about the x's here. So -5 to -2, we talked about how to do this in the previous sections. It's -5 less than x less than -2. They're not underlined because they're both open circles, and that one's done. All right, we have one more piece to do here, and that, what's the equation of this ray right here? So we have a ray, we have a line segment, now we have another ray. Okay, well, for this ray, we have a point. It looks like -2 comma 0, so -2 comma 0. And do we have a slope? We don't have the slope explicitly given to us, but we can count the rise and run on the graph. That's what we can do. So let me zoom in on the graph a little bit. If you look, you can see what's called a lattice point here. A lattice point is a place where the line crosses the crisscross of the graph, exactly on the crisscross right there. There's also another lattice point right here. Okay, and there's another lattice point right here. So what you do is you look for lattice points, places where the line that we're talking about here intersects the lattice of the graph, meaning the crisscrosses of the graph. Okay, and you can use those to count your rise and run. So it looks like we're going up 1 box over 2 boxes. Up 1 over 2 means your slope is 1 over 2. Now technically this is really going up 2 and over 4, because you can see this graph is going by 2. So this is up 2, and then to the right it's 2, 4. But that's the same thing, isn't it? Isn't 2 over 4 the same as 1 over 2? Does not just reduce to 1/2? So either way, your slope is 1/2. So we know our slope. Let's zoom out. Okay, go back to turquoise. Our slope is 1/2. So we have a point, we have a slope. Do we have a y-intercept? Unfortunately, no. That's a 0 for y. Your x would have to be, in other words, if it was 0 comma, if that's a y-intercept right there because the x is 0, but we actually have it the other way around. We have an x-intercept. We actually have something here that's touching the x-axis, so it's not a y-intercept. You could estimate where this is, but to me it's not a lattice point, so I don't want to assume that I know what that is. So we have a point, we have a slope. We're going to have to use point slope yet again. Y minus y1 equals m times x minus x1. This is going to be your x1 and y1. And here we go. Y minus y1, which happens to be 0, equals m, which we said was 1/2, times x minus, and x1 is -2. So this becomes a double negative right here. So that's a positive. And this is y minus 0, so it's just y. And now we have y equals 1/2 of x plus 2, just simplify that. And now we have to distribute that 1/2. Now luckily for us, this is going to be easy. 1/2 times x is just 1/2 x, and 1/2 times 2 is just 1. Okay, and that is our turquoise. I'm just going to box it with a turquoise box here. Our turquoise function, our third function. So 1/2 x plus 1. So come back to your piecewise function here. All right, and it's 1/2 x plus 1 for, okay, and just be consistent. If you're going to use the comma, use a comma for all 3 of these. If you're going to use 4, then use 4 for all 3 of these. I'm using 4 right now. I could have just as easily used a comma here instead of the word 4. All right, so we got the function. Where does this function live? What is its domain? Okay, its place of residence. All right, so it starts at x equals -2. You can see that, right? And goes to the right, so greater than. So x is greater than -2. It's a closed circle, so it's greater than and it's equal to. So what we're going to have here is x is greater than and equal to -2. And now we're done. Okay, there's your answer right there. So this does take a fair bit of work. Okay, for each piece you have to calculate the equation of the line. That's why we did that in the beginning of the period. And you also have to write an inequality to tell you whether it's a ray. This is a ray going to the left because it's less than. This is a line segment because it has 2 endpoints. And this is a ray going to the right because it's greater than. Remember, for the line segments, it's always less than, never greater than, greater than. You're always going from low to high. And this is what your answer will look like. So all of your answers in the homework tonight should be formatted like this. Okay? And like I said, you could also, if you really want to, use a comma. If you want to write a little bit less, you could use a comma instead of the word for. So that's up to you if you want to do it one way or the other. Okay, that's it. See you at the next video.
Check this.